Much. All right, so moving on, for the next talk, we in this world full of so many options and so many possibilities, we often end up thinking what to choose from all this plethora of actions, and we end up asking quite a few people. They give us some recommendations, and sometimes we like it, sometimes we don't like it. There is no success rate to how successfully you get recommended for the choices you make for those actions. So to solve for that problem, we have our own in-house recommendation system that we have built, and our next talk is going to be on that. And to present the talk, we have the swag of Delhi and grandeur of Rajasthan, Bhavul and Nitin coming on stage to present the next talk. Bhavul and Nitin.
Can you all hear me? How's the Josh? I don't think you can hear me. I'll do that again. How's the Josh? Good. All right. So Nitin and I will be presenting on recommender systems. We'll also talk about why we have named the slides like that. The whole presentation is divided into two major parts. One is recommender systems 101, so where we'll just talk about basics of what recommender systems are and what kinds there are, and we're going to explain it in a very basic manner. Second part is where we go into details and we talk about how we have built the recommender system behind Dekho app. You've already heard a bit about Dekho app, so you might want to know about that. So the first thing that comes up is what is a recommender system. So Swati, if I ask you, do you like to have more rice or more chapati? Chapati, right? And that's something that has come from childhood probably, right? Okay. For me, it came from childhood. Dad suggested to have more chapatis, and it so has been the case, right? And that's early stage childhood recommender system, my dad. Okay, and throughout your life, you have faced a lot of recommender systems, offline, online. Online versions are available everywhere on almost every app that you have right now. If you join Zapper, say tomorrow, you're going to connect with Sandeepan probably, and the next day LinkedIn's going to offer you to connect to other people, right? So that itself is a recommender system. Now my whole talk is will try to not get into any geeky terms, any technical keywords, so that even people who are not so much into machine learning or technical wizardry of that sort understand the whole talk. So hence a recommender system is any system that recommends an item to a user. Cool. Why is it that they are everywhere now and every company is trying to make them or have data science teams that are trying to build recommender systems or products based on recommender system? The first and foremost use case of this is revenue. Amazon has excelled the most in it. Amazon's 30% sales revenue is still attributed to their recommender system and how they've built different sort of recommendation engines to put out products for you to buy. The second thing is discovery. Spotify nails this. Every Monday, you get a new curated playlist that is personalized to you, and you have newer songs there that you can probably listen to and understand what else is available in the world. Not only is this happening you as a listener, it's also happening a lot of music artists who are independent and who do not have a full band or who do not have a lot of money to spend on advertising. A lot of those songs are also making it up to common people due to this. The third thing is stickiness. Who else can relate to this meme? There have been plenty of occasions when I have started watching something on YouTube and it becomes this. I know now how to groom a golden retriever. I don't even have one. The last thing is personalization. I don't think any other company other than Netflix does better at this. So Netflix is already obviously recommending you movies and shows to watch, but they're going a level further. They are also changing the thumbnails depending upon the kind of person you are, Okay, so if you and your friend go home today and open Netflix and you happen to have similar recommendations, you are probably going to see different thumbnails depending upon if you're more of a thriller person, more of an action person, more of a romantic person, and that's the kind of system they've built onto place. So these are 4 major benefits that you get out of recommender system: the revenue, discovery, personalization, and stickiness, right? But is that all of it? So sometimes what happens, there is another hidden, deeper impact that recommender systems make, which we often forget to realize. So to understand that, let's try to go with a little story. When I joined Zapper, I met Lytton on the first day. Day 2 onwards, we started discussing a bit about Nolan movies because we happen to have that as a common interest. Few days go back, about a week or 2 go forward, it becomes a common everyday topic because it's a common interest that we share, right? So at some day down the line, he tells me, maybe you should watch David Fincher movies as well, okay? And I do that exactly. I watched Gone Girl and I watched Seven, and these also were really great movies, I feel. So what happens is, after this, when I watch Fight Club, I don't like it so much. And I start thinking, has there been something that I have missed, instead of it being something that I may not have liked at all. The same thing happens with an app. So let's just replace Lytton with an app now. So I download an app on the first day. Second day onwards, I get some recommendations that I immediately connect with. Few days later, I'm discovering new movies of Nolan that probably I haven't watched. I love them. I'm building some sort of relatability to the app now. Maybe weeks down the line, I start thinking maybe there are some other things on the app that I can check out. What are the other recommendations it has to offer? And once I get to that, probably I end up watching David Fincher movies. And the same thing happens. Once I end up on Fight Club, I start thinking, instead of thinking, do I like this, I start thinking, should I like this? Okay? So the point I wanted to make is, recommender systems can eventually change your preferences also. Okay? They can shape up your preferences in the long run, and that's okay, because your friends do it too. Cool. The next thing is types of recommender systems. The first is very simple. So when you get onto, so first is what everybody likes, basically. So when I open Zomato, whenever I go home, there is this bestsellers list that is available. Why is it bestseller? Because almost everyone's ordering that and liking that, right? YouTube, Kabir Singh and its spoofs are right now getting into trending lists because it is popular right now. Play Store top apps is a similar scenario, right? So all these are cases of recommendations made to you to maybe watch this, eat this, or install this based on just the consumers that are out there and how much they are making it popular, right? And how active those things are. And this, hence, is called popularity-based recommendation systems. So there's no machine learning needed here, obviously. If you have an app, if we have an internal platform that hopes to get a lot of consumers outside, the things that they're using the most can be recommended to them, and it becomes a popularity-based recommendations. The downside is it's the same recommendation for everyone. Okay? You can maybe change it based on geolocation and stuff, but it will still be same recommendations to a lot of people. So the second kind tries to solve that and makes it a little more personalized. And the second kind, I want to quote it as, if you like Sprite, I'm going to offer you 7-Up. Okay? So an example again here would be, say say you love Kuch Kuch Hota Hai, then I'll probably recommend you Kabhi Khushi Kabhi Gum, Kal Ho Na Ho, or DDLJ, right? So what's happening here is you're getting some sort of personalized system that is recommending you whatever items it is recommending you, right? Because I know that you like this, I'm going to find similar stuff to that, and I'm going to recommend you that. So there is personalization in these recommendations, but you need to know what is it that the user likes at the first place. Third is benefits without friends, which also is the title of the talk. So let's try to look at this image now. Is everyone at the back also able to see the image? Yes? Cool. So we have a swimmer on the right side and a cycling guy on the left side, and both like to buy mushrooms, both like to have salads. And assume that you have an e-commerce or some sort of website where you have these two people in the database and what they are buying, right? Now what happens, you also know that the swimmer guy likes to buy energy drinks, okay? So what you try to do is probably energy drink might be a good option for the other guy also, okay? So you try to recommend that to the cycling guy. And this is where benefits without friendship happens, because these two do not know each other. They just exist in your database. They don't have any clue about each other, but you're still able to pull in something from one's lifestyle to and give it to another. A good example of this is you would have seen something like this on Amazon. Customers who bought this also bought. You're not getting to know which customers, but it probably suits your pattern and your lifestyle as well. This is also known as collaborative filtering recommendation systems, and they are obviously much more personalized than the first two, because not only can they detect the popular patterns, similar patterns, they are also able to detect hidden patterns, because energy drink was in no way related to salads or mushrooms, but you were able to still recommend it, right? The problem here is that you need a good chunk of users before you can switch to this method. Cool. So let's try to implement a recommender system. It gets this easy, especially in Python. Under 10 lines of code, I've imported a library which has recommendation systems implementations. I load a data set of movies. I train a particular algo, and then I predict for a given user what would be the rating. Okay? So in 10 lines, you can actually build a recommender system, and it gets that easy, but not in an ideal world. So when you're actually building for production users, all these other questions have to pop up. What about how you're going to refresh the data? What is going to be the data format? What algorithm is it that you're going to use? Will there be any biases that you're inherently adding to the system? And how are you going to scale things up eventually? And these questions don't just end up here. They keep on popping up again and again and again, and there are just so many bunch of questions that it does not end up being a 10-line code system. So implementation isn't so easy. Ultimately, it comes down to you testing out for your consumers what sort of recommendations work, what sort of system is working for you. And to be honest, there are plenty of systems out there on which there are enough tutorials, enough videos. This is this is something on the machine learning side, but it's much more laid out. Recommendation engines and recommender systems in general. So you can go ahead, Google it up, and you'll find plenty of videos discussing different types of recommendation systems built from as simple as just having something random being there to using something like scikit-learn to using something like deep learning. Cool. That was the first part of the talk. The second part is going to cover recommender systems behind Dekho. But first, what is Dekho? Now, Razvi although mentioned that there are too many choices nowadays, and there's a slide for it. You could have used it, man. There are too many streaming options right now in our country: Prime, Netflix, Vook, so on and so forth, right? And every day, if you like to binge watch TV shows in your free time, or you like to watch movies, there are too many options to choose into, and then you have to search in each of them and figure out which is the one that you probably want to watch, right? So Dekho is an app that basically solves that. It's one app with data of all the platforms. So inherently, that brings with itself a feature of universal search, which does not exist anywhere else right now. So you can search on this app about where does, say, Matrix exist, and it's going to tell you it maybe exists on Prime and Netflix both. You can click and directly go ahead and watch it. So this whole discovery of where what you want to watch exists is solved by Dekho. Second thing is it also provides you friends update. So you're going to get updates about your friends, what are they watching, what are their preferences. You can maybe interact with them on those front as well. And the last bit is, since this is one app having data of all the platforms, you're going to probably get much more personalized recommendations, right? So now that I've talked about recommendations, let's jump into that. There are 4 kind of sections that I've shown here of the recommendation that you're going to see in Dekho app once you download it. So they are like top picks for you, hand picked for you, top picks in English, top picks in crime, and there will be top picks in other languages and other genres as well. And there are two major recommendation engines on the back side. It's not just one. One we're going to be calling similarity engine from now on, and the other one will be popularity engine, and we're going to try to build these up now. Okay? Cool. So similarity engine, as I pointed out in the earlier slide, if you give it Sprite, it's going to output 7 up, right? So now if we have to build this similarity engine, let's just think how would we go ahead on doing that. The first thing that you'll probably want to know for building a similarity engine is how do you figure out what is most similar to something, right? So here's a simple live experiment. Let's ask this to our co-founders. Deepak, is he around? Hey Deepak, backbencher Deepak. So Deepak,
Hey, Bahul.
cool. So hi. Which movie do you think is the most similar to Kuch Kuch Hota Hai?
You already have it there. Kal ho na ho, best movie
Right.
ever.
So I asked him beforehand as well. Okay, time for Sajo. I'll make you run, Gigi. Sajo, what's your take? Is it Kal Ho Now?
Maybe K3G.
Kabhi Khushi Kabhi Gum.
Yeah.
All right. Sandeepan?
DDLJ.
Wow, okay. So it so happened I have those on my slides. Yeah, 10 points for me, thanks. Cool. So it so happens that we have those on our slides, and what I wanted to stress on here is that all three of them have answered differently, right? So most similar is going to give you a subjective answer. Not all the times, but many times, right? And if there's some subjective answer coming out from humans itself, you cannot expect that machine learning will completely solve that problem, okay? So actually what is most similar to a movie is the wrong question to ask. So let's look at this whole problem in a very different light. Swati, tell me the distance between A and B on this rectangle. इस पे मैच फिक्सिंग नहीं हुई है, you can tell. Okay, anyone else? Sharath? Ritvik wants to answer, yeah.
Equal to as distance C to D.
I want a value, if you can give that. Can you give me a value? A number?
5.
How?
If 5 on any, any unit, I don't know that unit, just as you said, just guesswork.
Yeah.
5 inch.
So actually you can't until I put a grid line behind it. So now it's going to come out to be about 3. Okay, let's talk about another example maybe. What would be the distance between Electronic City and airport? It does feel something like this, but approximately how much? 70 kilometers or so, right? The reason we are able to map this is, again, both of those points exist on a 3D plane where we live, and we are able to find the distance between them, right? So the same thing has to be done if you have to find distances or similarities or dissimilarities in between movies or shows in general. You have to put them on a plane. You have to give some numbers to each of the movie, right, to represent them, that what numbers does this movie represent. Okay, only then you can have a notion of distances between them, right? So geeks call these vectors. We're going to call these numbers in our slide. How do you decide what numbers you're going to keep? You don't have to. That's where machine learning part will come up. So let's try to understand now how we will assign these numbers. But before that, let's do a basic one-slide crash course on machine learning. Machine learning algorithms in general, any machine learning algorithm is just trying to do some things which are causing lesser and lesser errors, Okay, that's all they do. You pick up any sort of algorithm, neural network, support vector machines, backpropagation, anything that you want to pick up. It's ultimately going to do some things repeatedly and then cause lesser and lesser errors. So what are the doing things part here? Doing things part is assigning numbers. And error part we have to figure out, because we want to know that we have to assign numbers to each of the movie, but how do we figure out the error part? So the error part is where we want to utilize these 4 cases. So let's assume in a hypothetical scenario that there are 4 algorithms that were given by 4 different developers, which assign some numbers or vectors to each of these 3 movies. Kuch Kuch Hota Hai, Kabhi Khushi Kabhie Gham, and Gangs of Wasseypur. All right. Now, if you look at the first 2 cases, it says that distance between K2H2 and K3G came out to be 50, and distance between K2H2 Gangs of Wasseypur came out to be 2000. In the second case also, if you try to look, the distance between Kuch Kuch Hota Hai and K3G is lesser than Kuch Kuch Hota Hai and Gangs of Wasseypur, right? Which makes more sense, right? Because it's sort of correct. Gangs of Wasseypur is way far from these movies. So the first 2 cases are probably the correct cases, and the point I want to stress here is that the scale does not matter, the sort of distances you're getting. Okay, as long as the relative scale is kind of similar, it doesn't matter whether you're getting 0.5 and 30 or 50 and 2000. Okay, so first 2, if you have built up an algorithm that is giving you some sort of numbers which are giving you these sort of distances, you're fine with them. Third and the fourth are the cases where we have to worry. Because third, fourth cases, it says that K3G is much more farther to K2H2 than Gangs of Wasseypur. And that's where our problem comes up, right? And we can just generalize this error by saying something like this, right? The distance of K2H2 and K3G is greater than distance of K2H2 and Gangs of Wasseypur, then that's an error case for us. Now what do we have here? We have 3 movies through which we have defined our error, right? These 3 movies are usually called triplets, and this loss function or the error function that we have built is called triplet loss. Okay, geeks use these terms to say that which is the which movie. So we usually say base, closer, farther, or anchor, positive and negative. And if you have a data many such triplets, not just this one, and you feed it to any ML algorithm that you want to use, it's ultimately going to give you good vectors. Does anyone remember this whole contest that we had put up for Dekho? Yeah. So what you were essentially giving us was similar, somewhat similar, and not similar ones, which were essentially forming triplets for us through which we were training our ML algorithm. So yeah, basically we had to use some machine learning tech into the similarity engine. And there are 2 things here, doing things and error part, and we have defined both of them. Doing things is assigning some numbers to each of the movies, and error is triplet loss. And that is the machine learning bit of similarity engine, and that's my bit. Rest of the interesting bits will be covered by Nitin.
Yeah. So hi everyone, I am Nitin. So Bhaul has already taught us about how we go about making the similarity engine. Now let's talk about how do we pass inputs to this similarity engine algorithm. Fine, Swati. So basically what we input is plot of a movie, genres, which language the movie is in, the cast, crew, release date of the movies. So these all things go into our triplet loss algorithm, and finally we end up getting the movie numbers, which are the vectors as we call them. And is it a simple task to build a similarity engine? Let's see. So these are basically 14 movies we tried doing the similarity engine thing with them. So you can see the web network here. It's sort of not very easy, and let's take an example of IMDb. There are approximately about 3 lakh movies in IMDb, for which we'll have to create similarity for each and every pair. So how much that amounts to? 720 GB. Razvi, can we have such a server? 720 GB RAM? Yeah, so that's the case. So definitely we had to come up with an alternative. First of all, we tried to do it iteratively, one item versus other. That also caused a lot of time. So the solution for this was using an already built solution by Facebook. This was the PySpark NN library released by Facebook. This basically helped us a lot. It calculates the similarities, approximate similarities very fast in that manner. There are some alternatives as well, like Annoy, Faz, etc. But this suited our purpose the best. So we went about going and using this library. Now we are sorted. We know that how the similarity engine works and what are the difficulties, etc. We may encounter while building this similarity engine. Now, for similarity engine to work, we need the user's favorite movie, but we do not have it as of now. So how do we go about getting the user's favorite movie? If we go and ask the users what kind of movies you like, we'll just probably get 2 or 3 inputs from a user. So we did this slightly different way. We asked user about their preferences, what genres do they like, what languages do they like, which platforms do they use, and what are they more of a movie fan, they are more of a TV show fan. And still, we do not have the user's favorite movies. So we try to deduce what kind of movies the users might like based on these preferences of the users. Now, to make the life of user easier, we sort of thought of coming with a little game of ours, which we call Likeometer. So here you just need to swipe right or left based on whether you like a particular movie or not. And in this process, you also end up giving us way many inputs as compared to when we sort of ask you directly what kind of movies you like. And Bhavul surely does not like Breaking Bad. That's fine. Now come to what all goes into this Likeometer. So to start with, since we do not have much of the user preferences, we are mostly reliant on the popularity based engine, and we also throw some random elements to you just to discover whether you like some other genres or not. As you give us more of your preferences, we shift towards the similarity engine. And when you are using the app, you will definitely be watch listing some content. You will definitely be trying to watch some content. So we'll also take into account that as well when we are recommending content to you. Now let's see. We have gone through this slide. There are 2 types of engines, similarity engine Bhavul has talked about. So let's talk about what all goes into popularity engine. Popularity engine should be really straightforward, right? I mean, we have the language, genre, preferences, and we just serve you with these top movies in those areas. But to start with, I also thought the same way. So we went about taking rating of the movies. So rating of the movie should give you a fair enough idea about how the movie is performing and how are the people liking it or not. But let's say me and Bhavul rate a movie 10. Would you be going ahead and watching it just based on the 2 choices? Definitely not. So we also need the number of votes as well. Then comes various biases in the data. So first of those would be language-based bias. So definitely there are more English movies in the whole universe which are rated on different platforms as compared to the Bollywood movies or some regional content movies. So we had to debias for them as well. Then similar to that, we had to do debiasing for other things, release date based, genre based, and type based. Type based, I mean whether it's a movie or a TV show. Definitely there are more movies around in the universe as compared to TV shows. So this is the whole popularity engine. Now this is a brief overview of our architecture. So basically whenever a request comes, it hits our caching layer which supports the requests. If the caching layer has the recommendations for the user, it serves it. Otherwise, it goes to the ranking engine, which is a combination of both popularity and similarity engine, and then we serve the requests. Now, would it be possible for me and Bhavul alone to build this engine? Definitely not. So we have this amazing team of ours to support us. And the future of Dekho. Definitely, we are going to work towards a collaborative-based model as our user base grows, We are going to scale up our production levels so that we can support those users. We are going to explore other techniques in parallel as well. As of now, we have just considered the content vectors in a specific manner. We are going to try word-based embeddings, etc., those things as well. And then definitely we are instead of asking users about different preferences, we are trying to implicitly know whether a user likes a particular thing or not. And then key takeaways, definitely recommender systems help in discovery, revenue, stickiness, personalization, all those aspects. But they can also change your preferences, as Bahawal talked about. Don't expect something from ML algorithm which is subjective to humans. We already saw that even our founders could not agree on a particular thing. So yeah. Then sometimes there are biases in data, so we need to debias the data. And definitely, last but not the least, we are going to release Dekho next week sometime, so please download Dekho app. And we have your email IDs, will be sending you emails for that. Any questions? Easier ones to me, harder ones to Bahawal.
Nitin, I'm very sorry. If anybody has any question, Nitin and Bahawal are here. Just connect with them after. And if you have any questions regarding Dekho, Sharmi is around here. Just ask her. Very sorry in the interest of time.